Hello everyone, hope you're all doing well. Thank you so much for watching my videos. This video we're going to talk about pollution of the seas by using the ballast water. There are various kinds of pollution which you have heard of, like you have the water pollution, you have the air pollution, you have pollution by garbage, you have pollution by oil, you have pollution by exhaust. Today we are going to talk about a special case where how the ships pollute the seas by the ballast water and how it is being tackled using the international regulations. Okay, let's jump into the video and see what we have. Presentation on prevention of ocean pollution from ballast water. That's what is our topic. What is ocean pollution? Ocean pollution significantly affects marine ecosystem and biodiversity. Here what we are talking about is basically about the organisms which are the living organisms which are present in the sea or the oceans, which are affected by the pollutions or the pollutant which is discharged from the ships. Over 27 million tons of ballast water are discharged into oceans daily. First we have to understand what is ballast water. Ballast water is basically the sea water which the ships take into their tanks while discharging the cargo. While discharging the cargo, the ship becomes light, so it floats up where there is no cargo on the ship. So what happens? The ship becomes so light that it might be possible that it can become unstable. And also there is one more small requirement where the propeller which propels the ship also comes out of the water, reducing the efficiency. To avoid this, what happens is when the ship discharges, the ship also takes in seawater into the tanks so that the ship keeps submerged, so that the propeller is also inside the water for full efficiency and also the ship is stable. That is what is the ballast water. So once the ship loads, again it has to discharge the ballast during the loading operation. So that is why over 27 million tons of ballast water are discharged into oceans daily. That is, so many million tons of cargo is being loaded, so many million tons of ballasts are discharged. We will talk about where these tanks are there, how it is loaded and how it is discharged during the course of the presentation. An estimated 7,000 aquatic species are transferred in ballast water every hour of every day. Let's understand this. What happens is, once, for example, we take a case where the ship is loading in Persian Gulf and discharging in India. So during loading process, what happens? We discharge the ballast. Okay, so for example, the vessel is loading in Persian Gulf. So while loading the cargo, the ballast is discharged. So now the ballast tanks are empty and the cargo tanks are full. So the ship comes to India, and now what happens? The ship is discharging the cargo. While discharging the cargo, what happens? The ship has to take ballast. So during the taking of ballast, also the microorganisms and the aquatic species in the water where the vessel is discharging is also taken on board. Okay, so during this cargo discharge, it is loading of the ballast. While loading of the ballast in India, all the microorganisms come into the ballast tank. Now again we go to Persian Gulf for loading. In this time what happens? While we are loading, we are going to discharge the ballast again. So while discharging the ballast again, whatever aquatic species or the microorganisms we loaded during the cargo discharge port are being discharged with the ballast in the loading port. So that is why it is told an estimated 7,000 aquatic species are transferred in ballast water every hour of every day. This is a huge statistics where you can see the whole ecological system is being changed. It is possible that one species is incompatible to the other species in the loading port or the discharging port, because the ecosystem in both the ports can be much different. For example, if you have a long distance cargo loading and discharging from US to India or US to China, or you have long passage, then it is possible that the ecosystem in both the places are completely different and the species can be transferred to one port to another port. That is basically the cargo discharge port to the cargo loading port. The species will be transferred. So we will first see how the evolution of the ballast happened. So earlier times the cargo was carried in very small quantities, so that the ballast quantity was also very minimal. With the advent of modern day tankers, they started carrying large amounts of cargo in millions of tons. So what happened? They had to take lot of ballast, which changed the scenario where the number of species getting transferred were becoming huge. So we will just first understand the evolution of the ballast tanks in the modern day tankers. First came the clean ballast tank. Clean ballast tank is basically tanks where there was cargo before, that is crude oil or products. Mostly we are going to talk about tankers today, because the ballast tanks in other kinds of ships has been almost very steady, and the big alteration or the change in design has happened mostly in the tankers. Hence we will stick our topic today to evolution of ballast water in the tankers, and they are the most polluting as well. Hence it is ideal to take tankers for the example. Okay, so what is clean ballast tanks? As I informed, clean ballast tanks are basically ballast taken in cargo tanks after cleaning the cargo tank, as simple as that. Okay, so for example, if the vessel was, again we will take the example of Persian Gulf to India. If the vessel is loading in Persian Gulf, the cargo is being loaded and the ballast tank will be emptied. Again it will be happening in sequence. The ship has 4 ballast tanks, so it has to be cleaned and then it will start loading. When it comes to discharge port, it will discharge the cargo, and once the discharging is complete, the vessel will start loading ballast after cleaning the cargo tank. So in that case, what happened, the cargo residue will be again pumped out to the sea. There will be crude oil, there can be products, so it will be cleaned first, but again the cleaning was supposed to be discharged through the ODMCS to the ocean, and the remainder cargo was left below, and which was again load on top. All those things happened. So we will not divert much from the topic of pollution. So overall you can understand that the clean ballast tank used to load ballast in cargo tanks after cleaning the cargo tank after discharging operation. So what happened, the ballast with the oil traces will be loaded onto the ship. Okay, while coming to the Persian Gulf, again we used to discharge the clean ballast tank and then of the ballast and then load the cargo. Okay, so what happened, the ballast we discharged with the oil with the microorganisms. CBTs are designed to carry ballast in cargo tanks after discharge, minimizing contamination risk. Initially used for stability, CBTs led to pollution due to uncontrolled discharge of ballast water containing invasive species, including the oil which was there in the previous cargo. Introduction of non-native species disrupts local ecosystem, leading to biodiversity loss and habitat degradation. Okay, so simple English for this statement is the invasive species could be transferred from India to Persian Gulf while we are discharging the ballast in the load port. Here the clean ballast tank had one more reason of worry, where the oil was also being discharged which was present in the previous cargo. Regulation evolved to mitigate pollution from ballast water discharge, prompting the development of new tank designs. So what happened? The invasive species were being transferred. However, the main concern now was the oil which was also being transferred with the invasive species. So we had to have a better tank design where we wanted to first segregate the ballast and the cargo tanks. We did not want to mix cargo and the ballast. So that's the next slide where the advent of segregated ballast tanks came into existence. Segregated ballast tanks were developed as a solution to pollution issues associated with the clean ballast tanks. Clean ballast tanks, we were loading cargo in the same in the ballast in the same cargo tanks. So that was creating, where we were discharging ballast, there were traces of oil from the previous cargo. Located on the side of the ship, separating ballast from cargo areas, but still exposed to seawater at the bottom. Here the design was, you had segregated ballast water tanks on the sides of the ship, and the bottom was still open to sea. On the sides we had ballast tank, and in center we had cargo tanks. So the requirement of filling up ballast in cargo tanks after the discharge of cargo was nullified and did not require again, as the cargo and the oil was separated completely and the ballast was not loaded in the cargo tanks. This solved one problem, where the oil pollution to the sea was taken out completely. However, still the case of invasive species or the ecosystems from one port to another port still remained. Reduced risk of contamination between cargo and ballast water, this is very evident. The design does not eliminate pollution risk during grounding incidents, as oil can still seep out. Again, if the vessel grounds, then again, as I told you, the bottom is still open to the sea and it is directly connected to the cargo tanks. So if there is a grounding, it is still possible that the bottom might get ruptured and the oil will seep out to the sea. So here comes the next advancement in the ballast tank design, which is called the double hull tankers. Double hull, it itself, the name signifies there are two hulls, okay, one outside, one inside. Then inside the hull, inside the second hull, there was cargo, and the outside hull there was ballast water. Following the Oil Pollution Act of 1990, that is OPA 90 it's called, in the USA, double hull requirements were introduced to enhance safety and reduce pollution from oil spills. We are now presently talking about pollution through oil. We have still not touched the invasive species being transferred from cargo discharge port to cargo load port. Double hull tankers feature an inner and the outer hull, providing an additional layer of protection against spills and leaks. So here what happens, even the bottom had a ballast tank. So even the vessel grounds, this chance of oil leaking out to the sea is almost zero. This design change has led to significant decrease in pollution incidents resulting from tanker accidents. Okay, if you have two ships in place of one, obviously you are going to reduce the risk of collision or grounding. Then now it is completely segregated, the ballast and the cargo. So the oil going out to the sea is almost zero. Now came the focus to the invasive species we were talking from the first slide. There comes the ballast water treatment systems. What is ballast water treatment systems? Ballast water systems are designed to treat ballast water before discharge, ensuring compliance with environmental regulation. It is very similar to what you have water filters at home, which filters the water before you drink. It is not to that extent it becomes drinkable water, but again the system effectively removes all the organisms from the water before being discharged out to sea in the cargo load port. Physical methods: filtration and UV radiation, elimination of harmful organisms. These are the elimination or the treatment methods. Advantages: reduce risk of contamination between cargo and ballast water. The design does not eliminate pollution risk during grounding incident, and oil can still seep out. Okay. This ballast water treatment system, you have to understand, it only talks about the organisms. Okay, it is just a system fitted through a pipeline, and it does not prevent any oil pollution. If the vessel grounds or it has a collision which ruptures both the outer and the inner hull, still oil pollution can happen. So it is not a advancement to double hull tankers where you can tell ballast water treatment system will prevent all kinds of pollution including oil and through microorganisms. It is just a system in line of the discharge system where it will only cater to the organisms which will be nullified before the ballast water is discharged to sea. Pros and cons: protects marine ecosystem from preventing the spread of invasive species, obviously. Complies with international regulations, avoiding penalties for non-compliance. Again, obviously you have to have a ballast water treatment system to avoid fines and penalties, where there are some countries which are very strict about their ecosystems and they don't want ships coming and loading, that is cargo loading and discharging ballast in their waters, bringing in more of invasive species which can create diseases in their ecosystems. So they are very wary of it, and they can put large amount of penalties and they can ban the ships. So obviously you have to have a ballast water treatment system. What are the costs? High installation and maintenance cost for ship operators can be a barrier. The treatment plant itself is very huge and also cumbersome, and it also is very prone to breakdowns. Okay, so it's a new developing system, so it is still not very much settled, hence we continuously or regularly have issues with the ballast water treatment system in all the ships, in all kinds of vessels across the globe. Hence it becomes an operating nightmare for the managers to ensure the ballast water treatment system is always operational and efficiently removes the invasive organisms from the ballast water before discharge. Potential operation challenges during treatment processes, that is what I told about breakdowns. Variability in treatment effectiveness based on water quality and organism types. You cannot have one size fits all. There are various kinds of organisms, there are various kinds of species. So one treatment may not be effective against all the species in the whole world. So there is a certain amount of bias where when we tell it is the system cleans of all organisms, it is still possible that there are some organisms which escape treatment and gets into the ecosystem of the country in the load. Okay, that completes a small video on the pollution which was caused by tankers and the microorganisms and the species which are being transferred from the cargo discharge port to the cargo load port. I hope you got a fair idea of how the transition of organisms happen, and also how does the ballast water treatment system plays a role in reducing the change of ecosystems, thereby keeping the ecosystems in both load port and cargo discharge port intact. Thank you so much for watching my videos. If you like the videos, please do like and subscribe to the channel, and also share it with other colleagues. And also I will request, if you need any special topics which need to be covered, you can mention in the comments and I will take it up in the upcoming sessions. Thank you so much. Take care. Bye bye.